Number 3.
Number 3.
You said
Speak loudly. Increase your voice, please.
You told us to do the schematic circuit diagram from the electronics system by using paper and
on paper, not by using paper. On paper.
On paper and the electronics.
We'll be using pencils and hand. We'll be using pencils, rulers, not by using. By using manake tunachora kwa kutumia. Hii tunachora juu ya. Okay, keep on with your question.
And the electronics
simulators, yeah.
Which kind of electronics?
We have 2 types of electronic simulators. Offline electronic simulators and the online electronic simulators. Example Proteus, example Multisim, example is a circuit. I will mention them. This is just giving the overview. There's a particular topic which is talking about the simulation workbench, and I'll teach you about that. Okay? So, I gave you an example for electronic simulators. Electronic simulators, these are the software help you to do simulation. First of all, to draw the schematic electronic diagram or schematic diagram, and secondly, they can help you to draw to simulate or to test your circuit, and also they can help you to draw even or to design the PCB layout or to implement the PCB layout. So all of those we call them electronic simulators. Because we have also sometimes we have what solid work simulators in mechanical system. Okay? Yeah. Thank you for your question. Then next, Nancy. Now she has a question. This is Nancy who is asking a question. Welcome.
From the 7th objective.
Yes.
I wish to know those small-scale electronic engineering real-life problems.
Okay. Thank you very much for your question. We have our last chapter, which is the 12th chapter for this module. I will be mentioning those small-scale real-life problems. But I can give you one example. One example that any electronic system needs power. Any electronic system, whether your watch needs power from the battery, whether your mobile phone needs power from the battery, whether your computer needs power, whether from the electric grid or from the battery, right? And sometimes, for example, for the computers, or for the mobile phones, you need power from from the high power, it means from the the alternating power supply. But there, in between your mobile phone and the socket, there is something we call the power supply, right? So that power supply is converting alternating current into direct current. So there's one of the problems that I'll teach you how you can. I will teach you on how you can solve is what if. Means I will teach you how you can design a linear power supply that can provide power to your system, or to your device, or to your equipment that maybe you want to design. That's one of the examples. But another small-scale problems, also I will teach you how you can design or how you can implement a light-emitting marketing display. For example, you go to salon, welcome to salon, right? Yeah, you can design yours. Do you understand? I have just mentioned. We'll be just getting detail on all of these parts. Okay, you said, for example?
No, I wanted to say, so it means through this knowledge, you said you are going to base mostly on small scale.
Yes.
So through the knowledge that we are going to get, we'll be able even to solve those.
Once you go far, it means that you go extraordinary from what I'll be teaching. Yes, you can solve even intermediate small scale. But when I say that you can be solving small scale, it means that the knowledge you have, yes, it can help you to solve some small scale problems. Because once you want to deal with a large scale problems, you might need a knowledge that which we didn't teach you in this module. Maybe you need to take another module to have that knowledge. That's what we mean. So it means that because this is the last chapter, that's why I say that this is the last specific objective. We'll be now see how we can apply everything that we've been learning from the beginnings to the chapter 11. Did I answer your question?
Yes.
Thank you very much. Now, Isaiah, Engineer Isaiah.
Swali langu umesema utatufundisha tu kuchora hizo hapo diagram kwenye hizo software. Je, kutufundisha ni kuangalia problem kwenye circuit kwa kutumia software?
Ya, nitaelekeza pia hiyo. Kwa naposema kwamba maana yake kwamba to draw the schematic circuit diagrams of fundamental electronic system on paper and electronic simulators. Yani hiyo specific objective pia na kutest, sio tu kuchora, na kuitest. Kama ina shida unafanyaje? Na sio kwanza kutest, yani cha kwanza uelewe hiyo unachotaka kutumia kuchora. Unajua wengi wanaambia tunachora hivi alafu inaishia hapo. Lakini kumbe kile walichokuwa nacho kina uwezo mkubwa sana, kina vitu vingi ambavyo mtu hajui. Sawa? Na kati ya kitu ambacho kimoja hapo, one thing which you will find that is actually that you can find most of these electronic simulators, they have so many examples. Examples that are schematic circuit which are running. Ina mifano mingi sana ambayo ameiweka kwa ajili ya mtu kujifunza kitu fulani. Na hiyo mifano wale waliotengeneza hiyo software ndio ameiweka na inafanya kazi. Signal anachosema, labda unataka kujifunza, maybe you want to learn how maybe to design what non-inverting amplifier. So there's an example there which it has been tested, so you can run, you can see, and even yourself you can try to build it. You can try to draw it and check if it is going to run or not. Okay? Thank you. So Mr. Isaiah actually asked the question that according to the third specific objective, you will teach us only to draw the schematic diagrams. How about testing and troubleshooting those schematic diagrams? That is Isaiah's questions. And they say that in this steady specific objective, because you see that the steady and the force. So here I will teach you how to draw, but here I will teach you to transfer your theoretical concept to practical domain. So one way that I can transfer your theoretical concept into practical domain, that theoretically you can draw the circuit on paper, right? But practically you can draw on the computer and test it. So now you have been transferring your theoretical that just you believe that if I do this way it's going to work, right? But now by using the electronic simulator, you can test, is it going to work or it's not going to work? Are we together? Jamani, sasa tunazochora kwenye mkono, hakuna namna ya kudhibitisha kama inafanya kazi mpaka tujenge. Sawa? Kwa unaweza kajenga kwenye computer au kajenga kwenye labda hardware workbench kama hizi. Tunaelewana? Kwa maana yake theoretically tulikuwa tunachora au tunaamini kwamba hii ndo full wave rectifier. Hii ndo labda diode tukiconnect kwamba tukitaka kuangalia ile diode kama inafanya kazi. Lakini sasa practically maana yake tunakuchukua kwamba ile wazo ulichokuwa umekichora. Basi sasa tukiweke tukiangalia kinafanya kazi. Na kifanya kazi kwenye electronics we have two, na tuna maeneo mawili. Inaweza kufanya kazi katika software na tukaangalia kafanya kazi katika hardware. Tunaelewana jamani? Hizi ni specific objectives, siku zote unazikuta ziko kama jumla. Unaweza kukuta moja inabeba vitu vitatu, vinne, vitano. Sababu la sivyo maana yake utakuwa na specific objective 20. Sawa. Now it's time for Tatu to ask a question. You're welcome.
From fourth objective.
Yes.
In this module, do all theoretical concept has practical application?
Most of them. Because you have to understand this thing, however that I will teach you later. The main responsibility of electronic scientists is to innovate, to discover new equipments, right? And then the main responsibility of an engineer is actually to use what has been discovered by scientists. Yaani manake kwa hivi, kuna wanasayansi na kuna wahandisi. Kimsingi sisi tunaendaenda tu kama Watanzania wengi wetu. Hatujui kwamba nini jukumu langu na nini jukumu la yule. Sasa duniani jukumu la wanasayansi ni kugundua vitu. Kimsingi hawagundui, ila ni kutumia kitu fulani kutengeneza kitu kipya. Sababu hakuna kitakachokuwa kinagunduliwa. Na anaweza nikakupa mfano. Kwa mfano kwamba labda tunaweza tukasema kwa mfano kama transistor au electronics, kwa sababu tutakuja kuona kidogo ka historia yake. Electronics ilianza karne ya 20. Sawa? Manake ndio kipindi ambacho semiconductor imeanza kujulikana duniani, si ndio? Lakini siku ya kwanza ambayo Mungu alipoumba ulimwengu, aliumba pia na hiyo semiconductor na ilikuwepo. Lakini kama huo mfano hujaelewa, labda naweza kukupa mfano. Ukifuatilia historia ya ndege au helikopta, utakuta labda imeanza miaka 1000. Si ndio? Lakini material yote yanayotumika kutengenezea helikopta yalikuwepo hata kipindi kile cha before Christ, BC. Yalikuwepo. Kwani chuma ilikuwepo? Taa ilikuwepo. Material yalikuwepo. Material ya kutengenezea yale material ya ndege hayakuwepo. Yalikuwepo. Au tukiangalia kwenye simu zetu, manake hizi simu janja. Nadhani wengi mkiwa wadogo wadogo kipindi kile zilikuwa zinaingia, si ndio? Lakini kwamba kipindi kile unafahamu vile vidogo vidogo vile kama vya rafiki yangu, si ndio? Lakini ukiangalia kwani haya material ya kutengeneza hii display hayakuwepo. Yalikuwepo, lakini binadamu hakujua ayatumie kufanya nini. Japo sisi tunaita nini? Innovation. Lakini sasa naweza kaita innovation. Lakini watu wengine wanakosea, wanasema ni creation. Not a creation. Mungu ndiye anaye create peke yake. Sawa? Kwa tukisema kwamba kwa mfano tumetengeneza smartphone ambazo zina uwezo wa kuingia kwenye internet, multitasking, si ndio? Okay. Kwa maana yake wanasayansi kama wanasayansi wanaweza wakawa na discover labda display. Alafu wahandisi kazi yake hicho walichogundua wanasayansi kinatumika kutatua tatizo gani? Sisi umeelewa hapo uhusiano? So we have electronics scientists and electronics engineers. We have electronics technicians, scientific technicians, and also you have electronics technicians, engineering technicians. Are we together?
Yes.
Are we together? Kwa hiyo, tatu, we have asked the question that it means that all the theoretical concepts have the practical domain. That was your question, right? I cannot say that all of them have practical domain, but most of them. I think if I use that kind of the language, it will be powerful for you. Now it's time for promise. You're welcome for asking a question.
What ways will you use to train the students outside the box?
What are the ways that we use to train students to think outside the box? One of the methods that I'll be using, I call it's student-centered. Or we call it just a problem solving. It means learning by problem solving approach. But let me just explain the first method that I will call it a student-centered learning system. Student-centered learning system means that this is the method I'll be using to make sure that the students is participating in understanding and even also in grasping that kind of the knowledge. How? For example, if I'll be teaching you maybe theoretically, I write that we are talking. Okay? For example, I write a question there. For example, I want to give you an example of the method that I mentioned about student-centered learning system. I can write a question there, right? Maybe example 5. Maybe I can ask you, okay, you'll be given a cube of the following dimension, right? And I ask you, find the volume. And then before I solve it, I give you 2 minutes to practice, to try to solve it yourself, right? After 2 minutes, then I solve it. So from there, you have participated already. Rather than if I write and I solve myself. Are we together? Are we together? So for example, maybe later on, I can write a real life small scale problem here. And then I ask you now, how can you solve this problem? So from there, I'm trying to push you to take the knowledge you gathered in the class and then try to put it together and try to fit it in the real life problem. Are we together? So that's one of the ways. But another way, it means that from one session or from one workshop to another workshop, I'll be opening your mind. So whenever even you are traveling, you can notice that here there is an electronics problem here. Here, what can I do here? How can I, and how can I figure it out? How can I control that one? So those are the ways to make sure that electronics, it means to teach you that electronics is not only closed, it means it's not only closed in the particular room that's called the workshop or a class. Even you are outside, electronics is there. Even at your home place, electronics is there. Even you are traveling, electronics is there. So now you are thinking outside the box. Because usually, you used to think inside the box. How? When you are traveling, you are thinking about continuous assessment. When you're traveling, you're thinking about group work. When you're traveling, you're thinking about 2 marks that you have missed to achieve your CA, your continuous assessment. When you're traveling, you are fearful. What questions will be asked tomorrow in the exam? So you are outside the class, but you are thinking inside the class. Are we together? Are we together? Yes. Am I correct? Yes, that's how I used to live. Stress over stress. Stress. One day, finish all of this stuff. But you have never spent even 10 minutes in a day to think about, now I'm in Ilala. Okay, God, can you show me electronics in real life problems that I can solve here? You have never done that. And you are waiting for somebody to do rather than you. Who will do it for you? And if somebody will do for you, what are you doing here? What did you come to do in this world? Did you come to study and pass exam? No, that's not the purpose. Are we together? Yes. So I think that you have got the picture. So it means from the first workshop, first lecture, I will be going. So you'll be this. I will be trying my level best to give you different ways to think outside the box. Different ways. I'll be challenging you. I'll be giving you the homework that I have to go and sit. Sometimes you know that you can even get so many problems on televisions. One is to stay, maybe one you stay there, you can see something, and then you can think, as electronic, what can I do there? Are we together? Yes. Okay, now it's time for Engineer Hilda to ask a question. You are warmly welcome.
Okay, teacher, my question is in objective number 5.
Mm-hmm.
So are you going to deal just with breadboard or other type of board we are going to deal with?
I'll be mentioning the 3 boards that we are using to implement circuits in electronics, but we'll be focusing on only one for this fundamental, that the breadboard. Okay, so now it's time. So thank you very much for your questions, and I want to appreciate. So you can, I want to congratulate you for asking questions. It's rare in Tanzania to find that students asking so many questions. So okay, so it's time for you to actually warm up your claps. Okay, and then I want to remind you the style of clapping your hands that you used in standard 1 or nursery school. So I'll be guiding you. So you know how am I going to congratulate you, including the online community? So I'll be Hongera, Imara, wow. Right? You remember that? Yeah. Nobody who congratulated you. All the people always they say that you are doing bad. Okay, so 1, 2, 3, 4. Hongera, Imara. Wow, engineering students. Okay, so thank you for the questions that you have asked me. Now, let me just keep on opening your mindset. Let me present to you contents. Say contents. Contents. Say contents. 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 Do you know meanings of contents? Yeah. Yeah, contents of the beauty of fundamental of I'm coming, somebody is knocking, I'm coming, practical nakuja electronics engineering. So the meaning of contents means what are we going to cover? What are the contents that we are going to cover? So from those specific objects, can you predict